this. So I'm going to go through it relatively quickly and just present a lot of information and show it to you. And the presentation, most people from on the presentation are from New Jersey. New Jersey, we have some legislation that went into place specifically dealing with this as of January 8th of this year. So there's laws in New Jersey requiring a lot of things I'm going to talk about. The presentation is more generic in nature, and I did that on purpose because the New Jersey legislation is based on CAI National's public policy report on condominium safety. So I'm going to, if there's things in here, I'm going to try and differentiate between what's from the public policy report and what's in law in New Jersey. The law in New Jersey pretty much mimics the public policy. I'll tell you that also. And it's very interesting because when I went through this morning, a lot of things in the New Jersey law came directly from CAI's public policy. I also know that there's at least one person on in the presentation in the audience today from Florida. And for those of you who don't know, Florida has what they've come out with called the Structural Integrity Reserve Study. I'm not going to go into detail on that, but if there's any particular questions, I'll probably take that offline. So because we also do work in Florida, so we're pretty familiar with the Structural Integrity Reserve Study in Florida. So I'm going to get going. And again, if anybody has any questions, feel free to jump in. And I'm going to share my screen if it works. Let's see. Can you all see this screen now? You should. I'm going to go from beginning. So, Jen, are we okay? You can see the full screen? Okay. So, and you see that one of the things I love is we have closed captioning on the bottom, or text, voice to text. And this is what I use for TV all the time. And my wife has been telling me for a while to get my hearing checked, because I always tell her to turn it up louder, which I just did. And my high frequency sounds are not as good as I thought they were. So, all right. But I also have a hearing impaired daughter, so it's pretty interesting, but I use it all the time. So I'm going to talk about structural evaluations, what they are and why you should have one done. Now, when you're all familiar, obviously, with what happened with Champlain Towers in Florida and how this all started, huge change in the industry for the good. Out of tragedy comes good things sometimes. And this is one of those times where there's some things that have come into our industry that have really shaken up the industry to make sure our buildings are safe. But one of the things that came into play very quickly is people were thinking that the cause of the tragedy was due to the reserve studies. But when the National Public Policy on Condominium Safety, which I was one of the co-chairs of the committee developing that public policy, we came to the conclusion pretty quickly that it's not just reserve studies. It's connected to the structure and the facade of the buildings and maintenance, which is a big part. So if you tie these three things together, this is what keeps our buildings safe. So when I go through the presentation, I've pretty much broken it down into these three parts. Not that I want to bore you, but this is just a little bit about me. And from the perspective of what we're talking about today, I don't like to see my name. So, but from the perspective of what we're talking about today, I've been very involved in CAI for a few years, as a lot of you know. I was national president a number of years ago, but when Champlain Towers happened, CAI immediately put together a task force to put together the public policy on condominium safety. I was one of the co-chairs of the original version. I was the only engineer that gets involved in structural engineering on the task force. Reached out to over 600 people across the country for input, and we came out with a public policy, which I'll show you a picture of in a couple of seconds. Also, as this evolved, CAI then said, we're going to update our reserve study standards to reflect preventive maintenance and structural integrity. And I was one of the co-chairs of that task force. And CAI also developed a best practices report on maintenance. And I was one of the 3 or 4 people that worked on putting together that best practices report. All these things are free. We can send you copies of the best practices report, the reserve study standards, all this stuff. Then CAI, about a year after this, or maybe more than that, decided based on feedback that we really needed to update the public policy on condominium safety to not just include the structure, but to also include the facades of the buildings. So they asked me to chair that task force, which I did, and the public policy on condominium safety was updated. And now it includes a few different things with some clarifying stuff in it. But one of the main changes is that now includes facade evaluations. which I'll touch on as I'm going through. So that's my involvement in this stuff. As a matter of fact, yesterday, CAI New Jersey had a webinar on legislative initiatives, and I gave a presentation on what the structural integrity legislation and reserve study legislation in New Jersey is about. So what we're talking about is to solve problems, not create more. So for example, I'm going to touch on underfunded reserves, no maintenance makes the conditions worse, and no inspections let the buildings age without even know you have a problem. So why? I went through this already. Champlain Towers. Last summer in New Jersey, we had a balcony collapse on a condo which killed a worker. The way this impacted two things. In the state of New Jersey, we made sure, which I'll touch on in a second, that balconies are included as part of the structural evaluations. And as well as the national public policy includes the facades, which include balconies. So this is you know, it was due to it was due to things we learned as well as this collapse that took place in New Jersey. In New York City last fall, there was a parking garage collapse due to lack of maintenance. And also there are a lot of things that happened in Florida based on new laws. I'm sure you read about it, whether you're from Florida or not, in regards to the safety, structural safety of a lot of communities in Florida, that all kinds of things have been going on. As a matter of fact, I was down in Florida on business about a month or so ago, and I was drawn to the site of Champlain Towers. So I went there and I walked around, and there's a board there with the names of everybody that died in that tragedy. So I was drawn to it because I've talked so much about it. Little background. All right, this is what the public policy on condominium safety looks like. And you see it says reserve studies and funding, maintenance and structural integrity. The reason why it says reserve studies and funding, because there are certain places where it requires, their statutory requirements require doing reserve studies, and there's some places that require doing funding. But in a lot of cases, it may say you have to do a reserve study or funding, but not both of them. And what good is doing a reserve study if you don't also fund it? So, for example, the new laws in Florida require that you do reserve studies and fund them. In New Jersey, it's very specific that you do reserve studies and fund them, which I'll touch on, and maintenance and structural integrity. So this is how it's all tied together. Again, link one is structural and facade evaluations. And here's what the updated reserve study standards that look like, that include structural integrity references and maintenance. And I'd be happy to get into that if you want me to, but that's probably another webinar. And then this is the best practices report on maintenance. All the things I just showed you are free. If you go to CAI's national website, you can download them as PDF files, or Chelsea and Jen, we could send copies of these to everybody who attends today, so you can have copies of all this stuff. So link one is structural safety. And let's talk about what is a building structure. And like I said, I'm going to go through this kind of quickly because I'm on slide 16 of 98 and I have 10 minutes left now. So what is a building structure? Building structure is what holds up the building. It's made up of columns, which are these vertical guys. I'm looking at my other screen. That's why I'm looking over here, because you can see the arrow, right? I think you can see it. So it's made up of columns, which are the vertical things that hold up the floors, the roof, that type of thing. It's made up of this bracing, which is this, well, you know, as a matter of fact, let me go to the next slide because it's a little clearer. Here's the building structure. It's again made up of the columns, which are these red guys. And these red guys carry what are called the vertical loads, like this arrow is the weight of the roof, the weight of the snow, the weight of all these type of things. Then you have the bracing, which is shown in blue. Now I've shown on here what happens. The wind blows, and just imagine this. If you have this rectangle with all these little boxes in it, and you don't have these blue things, if the wind blows, it'll fall over. Those blue things are called bracing, and they keep it from falling over. So that's part of the structure, because if the wind blows, you don't want it to fall over, but that's from horizontal loads versus vertical loads. You have columns, bracing, then you have beams, which hold up the floors and the roof. Then you'll see we've included in the structural integrity inspection the podium deck. This podium deck, and you probably all know what it is when you just look at this picture. It's this deck below the building that holds up the building and takes the weight of the building and brings it out down into the foundation. It's called a podium deck. Podium deck is included in doing the inspections, the structural inspections, because I'm going to show you some examples of the problems you have with podium decks if they're not maintained. And also you see here, there are balconies, but I don't have an arrow on them. But in New Jersey, the balconies are included as part of the structural inspection. In other places where they require facade inspections, generally the balconies are included as part of the facades not as part of the structure. And you know, as long as it's covered somewhere, but that's kind of what it is. But the primary load-bearing system is what's considered part of the structure that needs to be inspected when we do it, when we do our inspections based on all the standards. And just to show you, it's comprised of the columns, the beams, and the bracing that are connected to each other, that form a path which these forces, such as the wind, the snow, these kind of things, can be taken to the foundation. So picture this, the wind is blowing, it goes into these braces and goes back and forth, back and forth, back and forth until it gets to the foundation. The weight of the roof and the snow goes through the column to the foundation. The weight from the beams goes through into the columns and then to the foundation. So that's what it's mean by they're all connected that hold up the building. And I'll show you why that's important. But the term primary load-bearing system is a key term to understand, because when we do our inspections, it's based on inspecting this primary load-bearing system. And I'll show you why in a second. Here's an example of a primary load-bearing system. And you see, this is an actual building. Now you see it doesn't look just like this. You've got the beams, you've got the columns, and you have the bracing. This is a building that was under construction that I saw, and I took a picture of it. So what this is showing is the purpose of the inspection and why the primary load-bearing system is important is look at these red X's. If any one of these, the column in the bottom corner here, or this beam, or this bracing, if any of them are not maintained for some reason and rust away, this happens to be a steel building, then there's a possibility that if this column is rusted away, there's nothing holding up this section of the building and it will collapse. If this bracing disappears, rusts away, what's going to happen when the wind blows? The building can fall over. What happens if this beam rusts away? Then this floor can collapse. So the thing to keep in mind from this is that the primary load-bearing system is based on a system where if any one part of it deteriorates and disappears, the building can partially or totally collapse. So that's the thing to keep in mind when it comes to what is meant by the primary load-bearing system. The building facade, and this is now included in the national public policy. In the New Jersey legislation, it is not included because when the legislation was put together, we were dealing with the structure. And it's very hard to change legislation once it gets into the system. So in the New Jersey legislation, it does not include the word facade, but what it does include, you see this balcony here, and I put an asterisk next to it. And the reason I put an asterisk next to it is because although the balcony is really part of the facade, in the New Jersey legislation, we've included it as part of the primary load-bearing system to make sure it's inspected. And we were able to just add a word without changing the entire legislation. So the building facade is what protects the building from the elements, rain. It looks good, it makes the building look good. But probably the most important thing that we don't pay attention to a lot is that if the water gets through the facade, then it can get to this primary load-bearing system and allow it to rust away or deteriorate. So that's a very important part of this. So when you look at the facade public policy, as well as any other facade legislation, it's not just based on inspecting like the structure of the facade, the balconies, these type of things, but it also includes in it inspecting wherever water can get through, like joints that have expansion joints that water can flow through, to make sure that the water can't get through the facade. So that's a basic overview of the facade. This is what a facade looks like. In this case, I've got some things circled. This is part of the facade. For example, this is a concrete balcony, part of the facade. This is down here. This is the slab of the floor that holds up the floor. So just an example of what a facade can look like. There are a couple of standards out there that are referenced in both the national public policy as well as every legislation I've been involved in and every one I've seen, because we didn't reinvent the wheel. For example, on the left, you have the guideline for condition assessment of the building envelope, which includes the facade. And on the right is the guideline for structural condition assessment of existing buildings. They're both put out by the American Society of Civil Engineers. In the legislation and in the public policy, it says that it should be the latest edition of things. So the ASCE standard guideline for structural condition assessment of existing buildings, actually, I hate to say it, but it was published in 1999. And that's been used for many, many years. I don't know if you can see it, but ASCE just came out with this new book, and it just came out. It's called Structural Condition Assessment of Existing Buildings, and it just came out. So this is essentially an updated version of that ASCE standard that came out in 1999. So this just came out. And when you do the structural assessments, you should be using the latest version, which is this, because it says that book or the most current version. I will tell you, I've gone through it pretty much in detail. There are some changes, but more in terms of simplifying the way it's written rather than additions and things like that, because this is a pretty comprehensive manual. What do others do? We looked all around the world. In Ontario, Canada, they have specific requirements for structural condition assessments of existing buildings. And that came into place probably about 20, 25 years ago when they had a parking garage collapse in a condominium. They actually require that, I think it's every 6 years, as part of a reserve study, a structural review needs to be done in the buildings. The bottom one is Singapore. Singapore has the most comprehensive structural integrity inspection requirements I've seen for residential buildings, and it's called Safe Structures and Buildings, but it's pretty detailed. So we use these as references when we put together the CAI public policy. In regards to facades, there are many cities across the country that have facade ordinances where you're required to inspect the facades. And I'll use the corny joke that I use all the time, that all these cities are so concerned about something falling off a facade and falling on somebody, killing them as they're walking by, as opposed to the safety of the structure for people that actually live in the buildings. But a lot of these cities have facade ordinance to inspect it. The other thing that's interesting, a lot of these just include the structure of the facade, and they don't include like the expansion joints and things like that can let water go through it. So, but the facades have been around, that kind of thing's been around for a while. State of New Jersey, like I mentioned, after 2 years of working on this, it was put into law on January 8th of 2024. So some of the things I'm going to be talking about are actually our laws in New Jersey as of right now. And it says, see, we're in the beginning of legislation, it says the importance of structural integrity of residential buildings in New Jersey has become a growing concern for many, especially in wake of the tragic collapse of a high-rise multifamily housing structure in Florida, which was Champlain Towers. And this gave me new faith in our political system, which may be gone again, but because Senator Singleton in New Jersey reached out to us, CAI, to put together this law. So myself and Ed St. George and Dave Ramsey in New Jersey worked with the senator to put together this legislation based on CAI National's public policy. So I don't know what would have happened if CAI National didn't do the public policy, because I don't know what people would be doing to come up with their legislation. I was also on a task force in Delaware. Newcastle, Delaware came up with a legislative initiative absolutely for periodic inspections, including the structure and facade, as well as requirements for maintenance. That's been a law in Newcastle County, Delaware since, I guess it's May of 2023 already, about a year. If you look at the CAI National website, you'll see a listing under in their governance section of all the different states that have things in the works in terms of reserves or structural integrity, where there are legislation that maybe is going in the process, what's been approved, what's been denied, but you can see a listing of what's going on. So now, with covered building is a very important term to understand, because in the legislation and public policy, a covered building is a building that should be required to follow these requirements. So for example, in New Jersey, it's a definition. It says these are the types of buildings that need to do these structural integrity inspections, and it's called a covered building, which means a residential condo or cooperative that has a primary load-bearing system, like I talked about before, that is comprised of concrete, masonry, steel, or hybrid structure. Hybrid structure means really a combination of concrete and steel, for example, including without limitation heavy timber. Now I'm going to talk about heavy timber for a second. In a few seconds, I'll show you some pictures, because people say, heavy timber could be just any type of building that's made out of wood. But keep in mind, this has to have a primary load-bearing system of heavy timber, meaning that if one piece of that wood rots away, a portion or total part of the building can collapse. So keep that in mind. I'll show you a picture in a second. And building with podium decks, but not including an excluded structure. And I'll tell you what an excluded structure is in a second, because everybody's concerned, is my building included or not? Key point to remember is that structural integrity inspections are based on the material of construction. It is not based on the height of the building. So it's not high-rise buildings. There are plenty of buildings that are much shorter than high-rises that have primary load-bearing systems made out of concrete, masonry, steel, or any of these things. The difference is, which I don't think it's in a slide, I don't remember seeing it, but maybe it does. When it comes to structural integrity inspection, it's based on the material. When it's based on facade inspections, it is based on the height of the building. Most of the legislation that you see say that you need to inspect the facade if the building is more than 3 or 4 stories in height. I know that in Delaware, because I was involved in it, that it says 4 stories in height, but if it has balconies that are less than 4 stories, you still have to inspect the balconies, even though you don't have to look at the facade. But the difference is, for a structure, it's based on the materials. For facade, it is based on the height of the building. So that's a covered building. Now, I added these slides this morning to add some slides. So let's talk about concrete. Concrete is comprised of 2 different materials. It's comprised of concrete and steel reinforcement in the concrete. Concrete is very, very good in compression when you push it together. It's not good in tension when you pull it apart. Steel is very strong in tension. So concrete is made up of steel. The reason the steel is put there is because there are certain sections of a concrete beam or column where it may go into tension. You see that I'm a structural engineer, so I'm not going to go into a lot of detail, but that's why reinforced concrete has the steel in it. It's made up of 2 materials, reinforced concrete. So what happens? Common causes of deterioration. What happens when steel gets wet? It rusts. When it rusts, it builds up, it gets bigger and bigger. It loses its strength because it's not as big a diameter anymore, but it gets larger and larger, and it pushes out. So you can see here, it pushes out. As it gets bigger, it pushes out the concrete. Now, not to really bore you, but concrete is very bad in tension, like I said. So when you're pushing out the concrete, it gets in tension, and what happens? Sections of it fall out. So a common, very, very common cause of deterioration is structural. In a reinforced concrete, the steel on the inside gets rust because the water gets through the concrete. And I could go into detail about how to prevent that and different things that I can do, but it's very common. Water gets into the concrete, rusts the reinforcing steel, and then pops out the concrete, which then exposes the steel even more. It rusts more and more, and the conditions get worse and worse. This picture on the left is taken from a building that we're working on, where I think it's been fixed already, where the reinforcing steel rusted, popped out the quarter of the concrete, and then we had to go back and fix this, which I can go into detail how you do that, but this is a very, very common cause of deterioration in concrete. It doesn't take an engineer to tell you that you have problems with a reinforced concrete column or beam, because you can see the rust on the surface, you can see the conditions. You need an engineer to tell you how to fix it, but it's not, you can tell when these problems are occurring, which I'll show you some pictures of. Now let's talk about steel. It has the same strength in every direction. So it's not like concrete with 2 different steel, 2 different strengths or 3 different strengths. Here's a picture of what happens to steel. Again, it rusts. The one on the left is a beam that we went out and looked at, and this is what we saw. It rusted so bad that the steel was gone in this section. This is called the web, and this is called the flange, but I'm not going to go there. But it actually totally rusted out, so the entire strength of this beam was gone from rusting. The thing that makes it even harder to see is if you look at the right, in a lot of parking garages and below podium decks, the steel is covered with this fireproofing material, this white stuff, the fireproofing material. So you can't see the steel, but you can see signs of rusting if it starts turning brown. So on the right, we started seeing signs of rusting. We took off all the fireproofing, and this is the kind of thing we saw underneath. So, but steel, it rusts and it loses its strength. That's a problem with steel. Wood is a very interesting material. I'll show you where I really like wood, because wood has so many different things going on. Its strength, it varies. If you're going what's called parallel to the grain, it has one strength. If you're going perpendicular to grain, it has another strength. The other thing about wood is that if it gets wet, you lose a lot of strength. And if the temperature goes up, you lose a lot of strength. So it's a very interesting material to work with. But wood, what is it? If you can see it, you know if it's rotting and you're losing strength. Look at this bottom. This is a beam that was holding up a deck at a building we're working on. And from below, you can see it. Then you pull off the decking, and this thing is totally losing its strength. So this is common cause of deterioration in all these things is water. I mean, age, as buildings get older, just from age, They will lose strength just from aging, but as soon as you put water on them, it gets worse and worse. Interesting thing is, for people who are close to the ocean, and there's somebody here from Florida, well, there's oceans everywhere. But if you have salt in the water, the salt in the water can cause this deterioration of steel to occur faster. In Florida originally, and I'm pretty sure it's been changed, it said that the frequency of inspections for buildings within 3 miles of the ocean was more frequent than buildings that are further away from the ocean. I think it's been changed because it happens a little faster, but I think the change, so it's all the same. The other thing to keep in mind is salt in water. It doesn't just come from the ocean. Think about the parking garages and the parking garages in the north. The cars are driving in, they're carrying the road salts. The road salts come in and they go onto the structure and they can cause it to deteriorate faster. So the salt in water doesn't only come from the ocean. All right, now the podium deck. This is what a podium deck looks like. I talked about it before. It transfers the loads from the upper part of the structure to the foundation. It's generally, in many cases, cover the walking surface. It has planters and it conceals, and these things cover up the moisture barriers that keep the water from getting to the structure, which I'll touch on in a few seconds. I'm touching on it now. All right, so here's some examples. To the left, this shows deterioration due to the membrane failure. The water got to the concrete and then it got to the reinforcing steel, causing it to rust. Big problem with car parking decks is this, an expansion joint in the middle. An expansion joint allows the parking garage to expand and contract when the temperatures change. They put joints in so it allows it to move back and forth. These joints generally have a plastic type of cover on it to keep the water from getting through. It really doesn't make any difference in terms of the ability to expand and contract, but it keeps the water from getting through. If that plastic thing or whatever it is disappears and allows the water to get through, generally underneath, there's a beam on each side of that expansion joint holding up the podium deck. This is what it looks like from below. The water gets through and it rusts away the structure. And this structure is very hard to fix because they're right next to each other. It's a tough fix, but we've been involved in a number of them to fix these things. But keep in mind, if you see anything where water's getting through or an expansion joint that's not working right, you got to replace it because it'll probably cost you a few $1,000s to replace it. But a repair like this, if you don't replace it, can cost you $1 million. So common cause of deterioration. Here's some other pictures. To the left, it's failed joints in a podium deck. This is a podium deck. Below, you can see the water gets through. The podium deck gets to the structural, the reinforced concrete below, rusts out the reinforcing, and then it starts expanding and cracking the concrete beam. And I promise you, this doesn't have as much strength when it's cracked as it does when it doesn't. The right, I'm going to show you some more pictures of this. How many times you go into below a podium deck and you see gutters and things like this to take the water away so it doesn't drip on the cars? This is the worst thing you can do. If you ever see this in below any of your podium decks, you got to get rid of this and fix the water so you can save millions of dollars in fixing things rather than just trying to keep it from getting on the cars. Now look at this. Here's the gutter to get the water away where it's coming through this joint. Now what do you see underneath? You see rust signs because the water is being held there and you're not seeing what's going on to the structure of this beam because the water is sitting there. A lot of it is very, people try and save a few dollars and do things not realizing what's happening underneath. What's excluded? And I'm just going to show you pictures rather than reading the words. All right, here you have what's called frame-built construction or stick-framed, a couple different terms. But like I talked about before, this is not a primary load-bearing system made out of wood because if any one of these 2x6s that are vertical that holds up the walls or the floor, anything rots away, a section of the building or a portion of the building will not collapse. So this type of construction is excluded because it's not a primary load-bearing system the way I defined it. Here's a good one because this is a combination. Above it has stick frame, which is excluded, but below you have a podium deck and a primary load-bearing system made out of reinforced concrete. So in a building like this, you do have to inspect the primary load-bearing system underneath, but you don't need to inspect this type of structure above. Why is that? Because if there's a problem with this primary load-bearing system below and this column collapses, all these residential units are coming down with it. So but that's a combination of primary load-bearing system and stick frame. What also is not covered, single-family homes are not covered, and the clubhouse is not covered. So even if this clubhouse, for example, has the primary load-bearing system that I was talking about, it's not covered and does not require an inspection because nobody lives in it. That I'm not saying you should inspect it if you see a problem, but as far as legislation, public policy, these type of things are not included. It's based on residential housing that somebody lives in. So the planning for safety starts when the building's being built. People look at it and say, well, we don't have to worry about this until the building's 10, 15, 20 years old. But keep in mind that when a building is being built, if it's not built in conformance with the design drawings for the structure, it can create a structural problem. So in the public policy, it says that inspections shall be conducted by a building official with sufficient expertise, blah, blah, blah. And the certificate of occupancy shall not be issued until the individual performing the inspections provides certification the building was constructed in conformance with the approved design plans. And it goes on to say, and if it hasn't been, that there's certification saying it's equivalent to the design plans. So because if it's not built that way, then you're going to have structural problems later on. I will tell you that in the state of New Jersey, although the public policy says this is not included in the legislation in the state of New Jersey because we got huge pushback from the builders, from their lobbyists. And that's what there was huge pushback because they said, why do we need to do this if the municipal inspectors come out to inspect during construction? Most people felt that it should be included, but the builders gave big pushback, and we want to make sure that the legislation went through to protect the associations later on, especially. So this was taken out of the New Jersey legislation, although it still is in the public policy. See in the bottom, public policy, not in New Jersey legislation. All right, here it goes on to say that in addition to the structural integrity, I'm jumping to reserves and budgeting for a second. The public policy says to connect what I talked about before, structural integrity to maintenance and to reserves. It says that the governing documents should include a maintenance plan for the association and what should be done to maintain the buildings, as well as how often and the cost to do it. And I will tell you, what I'm talking about right now has been added to the New Jersey law, and the developers in the state of New Jersey are required to do this as of January 8th. They didn't really have a lot of pushback on this because it's like buying a car and it has an operating manual in the glove compartment or a disc or something, and you move into a community that's millions of dollars and it doesn't tell you how to maintain it. So it says provide a maintenance plan. It also says include in the association budget or the reserve study the cost to perform the tasks included in the maintenance plan. It says include in the association budget or reserve study the funds necessary to update the reserve study. It says it includes perform and fund the tasks included with the maintenance plan. That's duplicative. And if you're a type of building that has a primary load-bearing system that requires ongoing structural integrity inspections, the cost of those inspections and the timing should be included in the reserve study. This is in the public policy, and this pretty much word for word is included in the legislation, the law in New Jersey, that developers are now required to do this. The first inspection. For a building that has a certificate, when the law went into place or when the public policy, when you adopt a public policy, there's what I call the 15-year rule. I will tell you that in the public policy nationally, it's a 10-year rule, not a 15-year rule. But we got a lot of pushback in New Jersey that it was too quick. And we gave in and said, okay, we're going to use 15 years. But in the public policy nationally, it says 10 years. For covered buildings that have a certificate of occupancy that was issued more than 15 years ago, and I will tell you throughout the country, and I know in New Jersey, it's really prevalent that the buildings are older than 15 years old that have this primary load-bearing system. But if it's more than 15 years old, you must have a structural inspection within 2 years. So in New Jersey, that 2 years started as of January 8th. For covered buildings that are less than 15 years old when the legislation went into place, they must have a structural inspection within 1 year after the 15th anniversary. So that's the 15-year rule for the first inspection. The first report, it says in the legislation as well as in public policy, it should be prepared in accordance with the American Society of Civil Engineers. I went over it before. and provide any information or guidance necessary to maintain the structural integrity of a covered building. So I touched on this before. Subsequent inspections, this is the 5-year rule. In the national public policy, it says that the first inspection should be in 10 years. Up until the building is 20 years old, the inspections can be every 10 years. After the 20 years old, there should be an inspection every 5 years. That's because as buildings age, they deteriorate faster. So the public policy says 10 years, 10 years, and then every 5 years. Keep in mind, it's maximum of 10 years, maximum 5 years, because you have an engineering report done that says it should be in 3 years instead of 5. You have to match what the engineering report says. In New Jersey, it's the 5-year rule is there, but the first inspection is after 15 years, and then every 5 years after you have to have it updated. So that's what it is in New Jersey, and but nationally it's slightly different. All right, so subsequent reports. When you do a subsequent reports every 5 years or whatever the period is, you use the original report that was done as what's called a baseline report. It means that that baseline report establishes the condition of the buildings, and then the subsequent reports use the prior report to note any new or progressive deterioration. So if you do your first inspection report, let's say after 15 years, the next report after 5 years later would use the original report at 15 years to note any new or progressive deterioration. So, but then after the 20-year report is done, then that then becomes the baseline report, because when you do your next report 5 years later, you're measuring it against the prior report to note any new or progressive deterioration, and to set forth the covered maintenance required to address any new or progressive deterioration. And it says also, and this is in the New Jersey legislation as well as the public policy, it has to be provided to the covered building owner, who shall undertake measures necessary to effectuate the covered maintenance. So you got to give it to the owner to fix these things. New Jersey legislation and the public policy also says, and we do it in New Jersey, that it's the requirement of the engineer who does this these inspection reports to also give a copy of it to the municipal authorities. So when we finish our structural integrity reports, we are required to give a copy of that to the municipal authorities so they can look at it and see if there's anything that we say is in bad condition that needs to be fixed right away. And they get involved in the process because they are given copies of the report. The qualifications of the person who does do these reports, both in the national public policy as well as in the New Jersey legislation, it has to be a licensed engineer with the appropriate qualifications who's licensed in the state that the building was constructed. So keep in mind, just because somebody is a structural engineer does not mean that they have the appropriate qualifications to inspect an existing building. It's a totally different world when you're expecting an existing building versus designing a new one, but it does have to be a PE, a professional engineer. In New Jersey, there are also a number of local requirements that were in place even before this law came into place. For example, in New Jersey, there's Jersey City, Cliffside Park, and Hackensack that have ordinances. Now, keep in mind that if you are somewhere where there's a local ordinance that requires something and then a state law that comes out, generally what that means is you have to do whatever is the more critical. So you don't do the one that's less critical. So for example, if you go through these, all of these required in the New Jersey City, structural every 10 years. That's more stringent. Or no, that's less stringent because the law says, the state law says 5 years. But they require structural inspection every 10 years. They define what it is, and it doesn't exactly match the law, I will tell you that, but whichever one is more stringent. The structural, they have a list that you follow in Jersey City. Then in Jersey City, they also require that the facade be inspected every 5 years. Keep in mind that the state law does not require facades, but locally they do. So you do have to do the inspections. And it goes through the requirements of the facade inspection. Again, there's reports that you have to fill out, all kinds of things. Now we go to Cliffside Park, structural inspection every 10 years. It's interesting because the local ordinances define what is a governed building in different ways. I'm not going to get into that, but they do define it in different ways. They all say it has to be done by a licensed professional. Facade every 5 years. In Hackensack, they had a parking garage collapse a number of years ago. So they require all parking garages to be inspected every 5 years. And that's a local ordinance. Now, what does it look like? Let's see, how much am I doing? I got 16 minutes to do the next 38 slides. We'll get there. So what does it look like? You have when you do these studies, they're broken down into two types: a preliminary evaluation and a detailed evaluation. Preliminary evaluation essentially means that you look at the entire building. If you see any signs of deterioration, say rust on a ceiling or something like that, you can't see the structure behind it, or rust on the beams under the podium deck that you can see on the fireproofing, but you can't see the beam, then you have to put in your report that in your preliminary evaluation, you say that the next step is to do a detailed evaluation, which may be like we did in that picture I showed you, to take off the fireproofing so you can look underneath to see the structural steel. But there's a process. The first one that the legislation requires, and they all say this, is do a preliminary evaluation, and then they all say if you see problems, you have to do a detailed evaluation. So preliminary evaluation, I talked about what's included in it, identify conditions of concern, locations, corrective maintenance. Corrective maintenance means if you see something that needs to be fixed, you got to correct it, and you have to list it, what it is, timing for the next evaluation, and the need for a detailed assessment, which I touched on. What does it look like? It has a table of contents and attachments. Then you get into it as a description of the structure. For example, in this case, it has that this is a reinforced concrete building. The primary load-bearing system is made out of reinforced concrete. Now, this is what reinforced concrete looks like. You have the steel inside the concrete, and then this is what it looks like and where the steel is inside the concrete. So there's a description of the structure. Then this continues a description of the structure where these are concrete beams, these are concrete columns. And then up above in this report, we actually had the original design drawings. So we're showing that we know what's inside of those beams. We know where the reinforcing is. We know how it's built. So that's a description of the structure. Or a description of the facade, similar thing if it requires to look at the facade. Next thing is your investigation methodology. How did you do the inspection? In this case, to look at the structure, we started here, and this happens to be a parking garage below a podium deck. We walked back and forth, and this is the trail that we took when we did our inspection. So that's the methodology of inspection. For the facade, in this case, they had us do a facade inspection, even though it's not a requirement in New Jersey, but this is a New Jersey building. So in this case, we used a drone. We started at the top, we went back and forth and took pictures. So this is the methodology. Then what are the findings? We found in the parking garage, we found cracking, we found a number of different things. But let's see, how come it's not doing all right? All right, but I'll go into a little more detail in a second. But we found cracking. This is what the cracking looks like. But then what we did is we took the plan on the left and we identified which column we looked at. It said the observed deficiencies, none, 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 none. But in this original baseline, even if there were no deficiencies, we still took pictures of it, because when you go back to do the next inspection, now you're going to look at these to see if there are deficiencies. So here's a picture of each all the four sides of that column. Then the same thing, this is the concrete on the balcony, and these are called eyebrows, which can support the structure, but that's just a term that's used. But then on the right, it shows by the red boxes exactly where the pictures were taken. Those were taken by drones. Same thing here. This is another facade where we're looking at it, and this shows exactly where the picture was taken, and this is what the picture looks like of the condition. Now, here's a very important part of any study, and when you have anybody do a study, you have to make sure that they include in the report condition descriptions, so that when you look at the different locations, you can tell what the condition is and how important it is. For example, so the findings, their severity, you have either severe, moderate, or minor. This is just descriptions that we used. And then it would have a description, deterioration is visually observable, and then what the recommendation is. For severe, requires a detailed assessment and remediation in the immediate future. Moderate, requires a secondary periodic inspection within 12 months. Remember, we said that the statutory requirement in the public policy says nesting inspection in 5 years maximum. In this case, we say you have to go back in 12 months. Then the minor does not require immediate action. Areas should be inspected in 3 years. So irrespective of what it is, it's very important that you include the report, include condition descriptions. I know that in the city of Philadelphia, they provide you with condition descriptions that you have to use. So, but it's very important in the report so I can identify when you go through. For example, here is, on the left is the descriptions of the conditions. On the right, this is an inspection we did. Where's the location? And this is minor. For progressive deterioration, look at it in 3 years. So that's an example of what would be in a report. Here's another one. This was, again, what minor. location, and what it is. Now let's get into severe. Here you got severe locations where the reinforcing has gotten wet, it has expanded, and it's popped out all the structural concrete around it, and the reinforcing steel is rusting. So it's deteriorated concrete with exposed rebar. Rebar is another term for reinforcing steel. Severity is severe, so that means you have to do something to fix it. Here's another one, severe. This, believe it or not, is looking up from the bottom of a parking garage. What you see here looks like a beam. It's a combination of a beam and a trench drain at the bottom of a ramp. So picture this. There's a ramp that comes down, follow my arrow. The water flows down that ramp. On the bottom of that ramp, there is a trench drain to get the water to go drain away. That trench drain also has a beam around it. The trench drain stopped working. The water was collecting in this spot and going into the concrete, and look what it did to the concrete. It totally rusted away, and we were afraid this was going to collapse. I mean, within a day after we did this inspection, there was temporary shoring put in to support this area before it was fixed. This was a pretty decent sized parking garage, and not to criticize anybody, but don't you think that a homeowner or a board member or somebody or a manager or whoever who's walking by can see what's going on? But so there was temporary shoring put in because it was severe condition. And then you get into the detailed inspection, which include invasive testing, material testing, or the design and the repair. I just want to show you evaluation techniques. You don't have to always take things apart to see what's going on underneath them. This is just one example. It's non-destructive imaging where you can actually like take an X-ray of the concrete to see if things are rusting underneath and the condition, the location of the reinforcing steel and things like that. So keep in mind, the question comes up a lot. If things are covered and you can't see it like in reinforced concrete, how can you tell without taking it apart? There are ways to do it. It's non-destructive imaging is just one example. But that case I showed you before, within a day, we had temporary shoring installed. We designed it. And then this is the design of how it was fixed. Believe it or not, it took 6 months to get this fixed by the time they got a contractor. But here, if you look at the beam, you see this is a beam at the bottom of a ramp. Here's the trench drain. On both sides of it are reinforced concrete beams. And imagine what happens if this trench drain fails. It just collects water and goes into the concrete. That's what happened here. All right, so now, and I don't know if there's any questions about the structural part. Well, we'll hold them to that because I'm jumping into the reserve study. Updated reserve study standards. I'm going to go through this relatively quickly. This is what the public policy says, and this is law in New Jersey. In New Jersey, it says any association needs to have a reserve study done and fund it based on adequate funding. That's what it says. It says that if they don't have a reserve study, if they have a reserve study that is less than 5 years old, it has to be updated in 5 years when the legislation comes into place, and then it needs to be updated every 5 years after that. It also says, as far as an exclusion, we talked about excluding buildings from structural integrity, but buildings that can be excluded from doing reserve studies, and this I'm pretty sure matches the national public policy also, is that if you have less than $25,000 in common area capital assets, then you aren't required to do a reserve study the way the legislation says. The reserve studies need to include, and this is a significant difference in New Jersey from the national standard. It says that the reserve study has to include the anticipated costs associated with building maintenance. What the National Reserve Study standards say is that when you're doing a reserve study, you have to disclose whether or not the community is doing preventive maintenance. If they're not doing preventive maintenance, then you need to reduce the useful lives as necessary based on the fact they're not doing preventive maintenance. What the New Jersey law says is that you have to include the cost of maintenance. So big difference. It has to have, the association has to have a 30-year funding plan. So the question always comes up, what does adequacy mean? Because it always refers to, it has to be adequate reserve funds available to repair or replace the capital assets and the associate without a need for a special assessment alone. So if you do a 30-year cash flow projection and it does not drop below zero, that's considered to be adequate based on the New Jersey legislation. If you look at the National Reserve Study standards, while this is what's known as baseline funding, it's also the most risky, and it's generally not recommended to do baseline funding except or go down to zero unless it's a very special situation where you need to catch up in your funding, and that's the way you have to do it. But when we put together legislation, everybody wanted it to be very simple. So what does adequate mean? Adequate means you have enough money. Now, keep in mind, even if you go down to zero and you update it every 5 years, hopefully you'll never run into a deficit because you're required to update it. But most communities are not going down to zero. They're doing some kind of threshold funding, which that's a whole other webinar, which I can give. But this is what the legislation says that as a definition of adequate funding. Now let's jump into maintenance. There are 3 different types of maintenance. Deferred maintenance, when you don't do anything. Preventive maintenance, when you proactively do something to make sure the things in your community attain their full useful life that shows in the reserve study. And corrective maintenance, which I mentioned before, is when you go out and look at something and it needs to be fixed. The reason I give you these definitions is because the public policy, as well as the New Jersey legislation, and I'm pretty sure the Florida legislation, uses the terminology preventive maintenance and corrective maintenance. So you need to understand what the differences are. What's the connection? I'm just about done. I'm going to finish on time. All right. So what's the connection between the 3? Here's a podium deck as an example that has a waterproofing membrane to keep the water from getting through to the structure. The podium deck membrane has a 20-year life, let's say. If you don't maintain it and it doesn't get to 20-year life, what's going to happen? The water's going to get through and it's going to get to the structure underneath. So then what's going to happen to the structure? I showed you pictures. It's going to rust away if you don't replace that expansion joint moisture thing that keeps the water from getting through. So here's the connection, that if you don't fund for reserves and you don't maintain, you can have significant damage that's going to cost you millions and millions of dollars more than what it would have cost if you would have just done this. So this is a slide for those who've been here before, I use it a lot, that if you take the cost of preventive maintenance, it's generally a range of 4 to 5% of your replacement cost. But if you don't spend the money of the 4 to 5% to do preventive maintenance, you're going to have to do corrective maintenance to fix something that generally costs at least 30, 40, 50 times the total cost of preventive maintenance that you could have been doing over the years. From a life cycle cost perspective, every association should be doing some type of preventive maintenance. Very, very important, key to the public policy as well as the legislation. It's very clear that in some instances, buildings have regulations that say that you can't do a special assessment or borrowing without a vote of the membership. Both the legislation in New Jersey and every legislation I know, as well as the public policy, says that if the board is aware of a structural problem with the building, they don't have to follow the master deed or other governing documents, and they can borrow or they can do a special assessment to fix it, and they kind of have an obligation to do it. But this one is actually from the New Jersey legislation. Notwithstanding, in terms of declaration, master deed, bylaws, or governing documents, the executive board may, without the consent of the owners or approval of the developer selling units in the planned community, adopt an assessment payable by the owners over 1 or more fiscal years, or obtain a loan on such terms as the board determines are reasonable whenever necessary to fund the cost of corrective maintenance of the primary load-bearing system. So this, if I'm not mistaken, some of this voting stuff became a problem in Florida in some buildings, but it's very, very clear that if there's a safety issue, you have to borrow the money. Here's just some pictures to show what you should be looking for. Again, this is an example of a gutter that was put in place so water wouldn't drip on cars. Now, if you look closer at what's going on there, you'll see that the concrete reinforcing steel is rusting away. This is very interesting to look at, because when you get rusting of the reinforcing steel, you see the rust. It's this brown stuff, the rust. It's coming through, the water's going through the concrete, you see rust. To the left, you see this white stuff. That's called efflorescence. If water is going through the concrete and you're not yet having rusting, you'll see the signs of efflorescence, which is the salts in the concrete coming through to the surface. The next thing you're going to see here is what's on the right, the rust. As soon as you see something with efflorescence, you should fix it so it stops the water from going through the concrete, so you don't get to the rusting, because that's going to cost you a lot more to fix. Again, gutters, or did I show this? I made the duplication. Here's a good one. They saw what was happening. The concrete was falling. The reinforcing steel was rusting. So what did? They put in a net so that the concrete wouldn't fall on the cars, but they didn't fix it. Here's the common thing in parking garages. You see these things to divert the water away. This is a building working on, you have all these joints between the concrete panels. One of them had this gutter. But none of the other ones did. I wonder why. It's because the water was coming through, and as soon as we took this off, we saw signs of structural deterioration there that was hidden by that gutter. This is my favorite one. I think this is slide 97. I always show it last. My favorite one, this is a podium deck. Water was coming through, and what they did is to keep the water from dripping on the cars, they put in this guy. It's like a corrugated thing that you use for siding, so to deflect the waterway to keep from dripping on cars. And they directed it right at this steel beam. So for years, this water's been coming through the joint, deteriorating in the concrete deck, and going against this steel beam and rusting the steel beam away. This is one of my favorite ones. You can see what's going on. The water's overflowing here, and you can see the signs of rust going on behind that fireproofing insulation. So now, I can't believe I did it. It's 10:30 exactly, but we started 2 minutes late. And so, are there any questions? I see there's some in the chat. Let's see. Jen, you want to read those questions?
So they're only about certification and getting copies of the recordings. Nothing else.
Oh, okay. Anybody have any questions? Please jump in. I covered a huge amount of information in 58 minutes. 98 slides in 58 minutes. I think that's a new record. Anybody have any questions or anything? Oh, come on, you got it, something. All right, well, if anybody ever has any questions, you have our contact information, just send us an email. There's never a cost for us to answer any questions. Send us a picture, whatever. And you're on our email list for webinars, so I'm sure that there's some coming up in the future that Jen and Chelsea will send you an email on. And if you have any suggestions for future webinars, let us know. And if you ever wanted something like this presented in-house to your staff, if it's a management company, just let us know, because we do that kind of thing all the time also. So with that said, have a great day, everybody. And thanks for showing up. We had 43 out of 87, not bad. 50%, just what I thought. All right, thanks. And by the way, this class, you do get continuing education units for this. So in order to get continuing education, you have to send to Jen or Chelsea an email saying, I need a certificate.
No, we'll send it. We send it to everybody now.
Oh, so you're getting it even if you didn't show up, you're getting
If you don't want it.
Even if you didn't show up, you're getting it. It's only to the people that show up, right, Chelsea?
Yeah, exactly.
Okay. All right. So you're all going to get a certificate, and have a great day. Thanks, everybody.
Thanks, everybody.